Writing recursive methods has its own little tricks. To come up with a recursive algorithm, you first have to be able to frame a process recursively, also known as in terms of a simpler case of itself. This is different from framing it iteratively, which repeats a process until a final condition is met, which is what we're used to with while and for loops. A good strategy for writing recursive methods is to first state the algorithm recursively in words. So the example we're going to use is we're going to write a recursive method that outputs an integer parameter with the digits reversed. So for example, if we type in 147, it's going to come out as 741. So we're wanting to describe how this is going to work. So we want to output the rightmost digit, then if there's still digits left, reverse its digits, repeat until there's nothing left. So this looks like in recursion, and I can get rid of this. This was our old one. Let's take a look at what this is going to look like. I have extra braces and apparently quite a mess here. There we go. So we'll bring this method up because I'm going to have to make this into a new method. Public static void. We're going to call it revdig. And it's going to receive an integer of n. This n's rev. Man, I'm not typing well this video. There we go. So we're looking at how to find the rightmost digit. So system.out.println will get the rightmost digit. We're going to make it just a regular print when it takes n and sees what's left over when divided by 10. Remainder. I'm doing the remainder here. And then we just simply check if n divided by 10 does not equal 0, because that means there would not be anything left in the ones digit. Then we run this again, but we reduce it by 10. So let me explain what's happening here again. We're pulling the ones digit out. Then we're checking to see if we divide by 10. If it does not equal 0, we continue going. If we do, that means that the last time it runs through, it's going to print that final digit for us. So let's pass down revdig, and we're going to make it go 532. We'll go with that number. So it should return as 235, which it did right here. So we can see, I'll even show you in a separate, figure out how to do it here. I'll even show you here in a separate print the value of n being reduced. So that's going to actually mess up how this looks. So we'll put a blank print line around it so that we can see it being pulled apart in this recursive method. Here you can see it starts off 532, pulls out the 2, leaves the 53. If n divided by 10 does not equal 0, which it doesn't, divides it out and reruns it again, but while it redefines what n is. So the next time it runs through, n is 3. Actually, n is 53. Goes ahead, pulls out the 3, leaves the 5 left over. And the next time what's left over is the 5, prints it out, divides by 0, there's nothing left. The recursion is over. So it's a little bit outside the box to think about. The big thing you need to be able to do is to look at a recursive method and interpret what is happening and work your way through it. And we're going to practice these very heavily. I'm going to show you some other stuff still with recursion as well.